Welcome to all of you, and we are very, very honored to have you with us. We've heard numerous times during our opening session that this can and must be a collaborative effort to build AI with trust, and therefore we have asked three inspirational leaders from three different sectors to join us and talk about their vision and what they themselves are doing. And we begin with the CEO of XPRIZE. She's internationally renowned for highly creative competitions that essentially incentivize solutions to humanity's biggest challenges. She was formerly CEO of Prodea Systems, a leading Internet of Things firm, and she made headlines as the first female and first Iranian Muslim private space explorer. Shall I say that again? First Iranian Muslim private space explorer, and then followed up by sponsoring the $10 million Ansari X Prize for commercial spaceflight. Please give a very warm welcome to the co-founder of the $1 billion Fund for Women and author of the acclaimed My Dream of Stars, Anousheh Ansari.
Thank you.
The floor is yours.
Thank you, everyone. It's a true honor to be here and be able to speak to all of you about this very, very important, critical issue that we need to resolve in collaboration, as was mentioned. I have a few slides to help me maybe frame the conversation, and then hopefully we'll have a very robust question and answer session. Okay, I think we're there. So I always like to start with a slide that talks about, if this works actually, next slide, please. I don't think my clicker is working. Okay. I'd like to start with this quote from Albert Einstein. I use it every chance we get because at the core of every innovation is human imagination. It's a unique gift we have. We develop it as children and we use it quite often. As we get older, we don't use it as often, and it's a sort of cause of some of the issues we face, or we limit our imagination, which is even worse. But a lot of the things that I will talk about today requires a little bit of collaboration on your imagination with me. Next slide, please. I don't think the clicker is working. So we live in an engineered world. This world will be more and more engineered as we make additional progresses. Every keystroke, every action we take, every transaction, every content we consume, AI is embedded in it, it surrounds it. Everywhere we are, every place we go, in our homes, in our schools, in our workplace, in our cities, AI surrounds us and is watching us. In every place that we are doing anything, AI is analyzing our actions and reactions, our environment, our emotions, and analyzing it to make decisions about us. And if we're lucky, in some places, Europe is at the forefront of that, we are actually notified that this is happening. If we are really lucky, we get to opt in into our privacy being invaded. And very, very seldom we actually have the opportunity to ask to opt in. But normally we have to opt out, and you have to figure it out in a very difficult multi-step process and reading 50 different documents. So everything is obscure. So in such an obscure place, trust is very difficult. So we need to keep all of this in mind. Next slide, please. Sorry, my clicker is not working. I think can you advance the slide, please?
I think we're having a problem with it. There we go.
Yeah, if there's another clicker you can give me, that would be great. The AI, as we know it, we think of it as something in a machine, somewhere in the cloud. It can be embedded in different devices that can be very, very useful for our everyday interaction. Now, XPRIZE believes in the positive outcomes that come from a trusted and well-engineered AI systems. We even launched a competition for AI for Good, which led to our collaboration and co-founding the AI for Good Summit that Jessup talked about. Next slide, please. It can really help develop, help us with abilities that we've lost. It has many, many applications in healthcare, in pharmaceutical, and a lot of it you are all aware, so I'm not gonna discuss. Next slide, please. I have to talk about space, of course. AI has been embedded in a lot of the work that's done in space, whether it was in fully robotic system or systems that enhances human ability or in analysis. Next slide, please. Not too long ago, an AI system has been launched to the International Space Station called Simone to help astronauts. We all watched the movie Space Odyssey, where you had the AI that was evil in space, but this one is very friendly and useful to the astronauts. Next slide, please. We are really fortunate that we can actually go back and look at the data that has been collected over many, many years, where we didn't have the compute power to analyze it and use AI system to actually gain new insights with the data that has been collected over the years. Now, today we're talking about AI and trust, but you cannot talk about AI and trust without talking about data, because they are completely intertwined. It is the data that really fuels and makes AI useful. And as such, if we don't have enough data, or if even worse, we have insufficient data, AI not only cannot be useful, it can be harmful as well. And we've seen this in many conversations around AI data gap issues, and the fact that the data used by some AI and machine learning system is not correct, accurate, and complete. AI is also helping us develop capabilities that we really didn't imagine is possible until recently. This is an example of using AI and embedding it. So AI doesn't have to always be external in cloud or in machine. It can actually start residing in us, inside us. So this is an artificial retina that has restored ability for someone to see, and furthermore, it's going to be connected to the brain and interact with the brain. Now, CRISPR technology is not an AI technology, but it was developed because AI made scientists capable of doing the analysis and the work they did in actually creating CRISPR. Now, technologies by themselves may not seem like they are able to come together, but we need to use our imagination on how different systems and exponential technologies can interact and really make things possible that we may not imagine possible. Next slide, please. We talked about designer babies, and we thought that, no, this is not going to happen. I'm using this as an example as to, if we just trust that scientists and engineers or governments or companies by themselves will make the right decisions, I can assure you it will not happen. And this is an example that some scientists were really upset about what happened, but it happened. And once it's out there, it's out there. And I'm sure there are people, parents out there who are actually seeking this type of technology. Now, we can also take this really far. So it's not just changing the color of someone's eyes, but you can actually start implanting using AI and incorporating it into a human body. Now, I'm a proponent of some uses of that for long-term space flight, because our bodies are not made for that. But when it comes to activities that may be for military use, I definitely don't think we all want Wolverine to join our soldiers in the field. Also, as I talked about in the scenario of the artificial retina, the advancement of combining artificial intelligence with our brain, and not only with a single brain, but connecting brains together, is another possibility that we need to be aware of and also think about ramifications of that, because this collective cognitive sort of ability can really advance what can be done and to what scales, because still our brain is one of the most sophisticated computing machines we have around. Now, this is an example of that type of technology being used for military application. And even though we don't like autonomous killing machines, they are also being built. And again, you talk about implanting this and incorporating this into our bodies. And this being a Borg or a cyborg or a collective Borg machine where we are all connected and can be controlled, it's also a possibility. These are not science fiction anymore. There was a time which was, we would watch this and we would think it's science fiction, but now it is truly possible. We have recently been able to actually grow a small sample of a brain organoid. And the organoid actually showed electrical signals that resembled a child's brain function. So if we can create artificial brains and we have artificial intelligence, we can really think about how we can advance and use this type of technologies. And I'll leave that to your imagination. All these examples just to show that it is easy to sit here and look around us and things look like, especially in this room, I've been in this room many times, looks like 20 years ago. But the world out there is not the same. And it's changing faster than policymakers and any one of us can imagine. And it's happening inside groups, small groups, closed groups. And it's happening in a way that we cannot even, figure out how to control it. So when we talk about trust, I think one word that we need to think about alongside of trust is transparency. Because if something is out there and we want to trust it, we need to be able to understand it. And unless we get to a point where there's transparency, where machine learning is not happening inside a black box, and we don't know how decisions are made, it's hard to create that trust. And with collaboration at this point in time, and with all the organizations that are present here and corporations, I think we can all get there. So as the lines blur and we need to be cognizant of that, I want to leave you with this quote, which is from one of my favorite people, Carl Sagan. We can judge our progress by the courage of our questions and the depth of our answers, and our willingness to embrace what is true rather than what makes us feel good. So I hope you always ask the hard questions and always seek those really in-depth answers to those questions. Thank you.
Anousheh, Ansari, thank you very much for that look at what might get us onto that exponential curve you showed us. And ladies and gentlemen, you can, of course, pose questions later on to all three of our keynote speakers. So whether you're online, you can send them in via the chat function on the live stream, or if you're here in the room, you can use your mics. I will open the session in a little while. Let us now hear from a leading scientist with 30 years experience in the ICT sector, developing products and ideas that have impacted the lives of people around the world. A regular speaker on big data, he has held senior posts at Nokia and currently teaches at the University of Technology in Sydney, Australia. Please give a very warm welcome for New South Wales Chief Data Scientist and IEC board member, Ian Oppermann. Okay.
I guess we have a small switch up.
I'm teaching
introduce
at EPFL, you, Rüdiger,
and all the credit goes to my next speaker. So I'll just tell you a little bit something about a technology perspective. I've been involved for 2 years with Jesta. I teach at EPFL, and it's Jesta is the Geneva Science and Diplomacy Anticipator, where we're trying to think about what might be ahead in terms of technology, and then see what the impact could be and anticipate it. So the question for us today is why trust is important in AI and what we might do to gain it. achieve it. So let me first try to start a little bit with perspective how we got here in terms of AI. This is not the first wave, of course, of AI machine learning. It's perhaps the third one, depending on how you count it. The last one was of very different nature. It was one in which intelligence or knowledge was kind of physically encoded. So you had lots of if-then statements. If it's raining tomorrow, take your umbrella. If you didn't have breakfast, stop by the coffee shop, etc. Okay, and so even though there was quite some excitement, of course, around it, it turned out that it didn't really have a lot of impact commercially, and so kind of the hype around it vanished a little bit until we got to the wave that we have right now, where systems are built entirely different. Systems are no longer built on kind of logic, but it's built on probabilities. You're simply computing, given the information you have, you're computing the probability given some model of what might be true, what is your best guess, etc. And so this very different approach, is what you might have heard of neural networks or deep neural networks, is what allowed us to have quite some astonishing successes. You probably have all seen these, distinctions between cats and dogs, but perhaps more impressive, languages. If you go on some known web pages, you type in, you can pretty much translate between any languages. All of these are probabilistic models. You probably have seen or heard that the best Go players or the best chess players are no longer humans, but of course, again, these kind of machines. And that even in very basic science, like things like protein folding, the record is now really held by a computer, again, using exactly the same technology. So that's what we have right now, and had already tremendous impact. Certainly a lot of attention has gotten there, and that's what brought us all here. So the question is, what might happen in the next maybe 10 or 25 years? Is that it? Are we basically already there and everything else is detail? Are we already close to, if the best computer can already play better chess than a human? Probably 20 years ago, people would have said, once that happens, computer basically, basically achieved human intelligence, right? But kind of the goalpost, as we're achieving things, is moving. And it's clear that computers are by far not there yet, okay? So, even though you hear all these things and the amazing accomplishment, there are many, many, many things that still have to happen in order if we want to go to something like, general artificial intelligence. But what might happen in the next maybe 10 years? One thing that computers are not particularly good at, but probably this will happen in the next 10 years, is integrating, for example, contextual information. You all know that you can speak a sentence, and depending what the context is, it might mean exactly the opposite of what you said, okay? And computers are really grappling with that, and it's not easy to teach them to take that into account. The other thing is like common knowledge, right? We all know some basic facts, kind of like Wikipedia facts. And it's not easy to integrate this kind of knowledge, this kind of basic relationships also between things, kind of higher also abstractions. It's very difficult for computers to teach that, right? So if you think about how a baby learns, a baby, of course, doesn't learn by seeing a billion pictures of cars and then knowing every single car. A baby learns by learning certain concepts, what a wheel might be, what a steering wheel might be, maybe what an engine is, and then knows certain relationships and certain physical or certain physics, and then we'll be able to recognize very easily, just seeing very few examples of potential cars, a variety of cars that look very, very different from the cars that we've seen. The computer isn't anywhere close to being able to do that. The other thing is that typically right now in systems, essentially most systems start from scratch. So if you want to teach a computer a certain task, you give it a billion examples for that task, and it might learn this task very well, but potentially even better than humans. But it's not particularly robust. If you have a task that looks to us human very similar, it's just saying switch that for that, maybe the hammer for a pair of pliers and something like that. A computer is not particularly good at learning that, and essentially currently, and I'm exaggerating, would have to start from zero. And that's what's called transfer learning. So just transferring knowledge, basic knowledge that you have, understanding the world, and just adding a little bit, some extra skill and making use of all these things. So all these things we anticipate will happen in the next perhaps 10 years or maybe 15 years. Two other things is robustness. Okay, computers are, even they might be fantastic good at figuring certain out cats and dogs, it's also very easy to trick them, either just by giving data that is a little bit noisy, or even worse, and that leads us to security concerns. If you're trying to trick it, you can make imperceivable changes to the input and very easily, if you're malicious, trick a computer. And again, so we have to learn, and that is happening right now and will happen in the future in the next 10 years, making these systems much more robust, of course, something that's very important. Two other topics. One is, and that has been mentioned already several times, interpretability, right? When we're making decisions, or then often we don't just communicate the decision, but we also communicate the reason behind our decision. At least ideally, that's what we should be doing, versus current AI systems often are giant, very capable black boxes, and it's very difficult to understand why a decision was being made in this way. Now, this is certainly going to happen in the next 10, 15 years. I think we kind of people know how to get there, how to address that, at least to some degree. If we're looking much further, right, you might think that perhaps in 25 years, we might have something like general artificial intelligence, where computers might be able, pretty much in any task that human can do, to have superhuman performance. But that's, of course, much more speculative, and we don't really know what the technology and the ideas would behind to make that happen. But it's also important, and I think 2 speakers ago, this was already said, our aim here is not really to get a computer to be better than a human, but simply to make computer systems that make real world systems that work for society, right? That should be our aim. It shouldn't be our aim to, also intellectually, it might be perhaps interesting to see, can we do it? But really, our aim should not be replacing humans. That's not what we're really after. We should make it work for humans. Now, so what do all these changes, all this progress that we'll make in the next few years mean, right? Essentially, I think the most important impact it will have is that currently, where computers are very good at, if we have enormous amounts of data. So we have 10 trillion dogs and 50 million cats, and we train the computer, and it will be perfect to distinguish if it ever sees another dog or cat, be able to distinguish between them. But what it's not very good at is what's called the long tail of problems, the myriads, the millions of problems that are there, in which we might not have the data, or there might not be any commercial interest of gathering this data, which after all is very, very costly to do. Okay, so, but all these things that we're talking about will allow us, with much less data, transferability, etc., to actually attack problems that are much more mundane, maybe interesting for not just niche markets, and still get extremely good performance. Good. Now, AI will also probably be, so what this will mean is that AI will be everywhere, okay? Even much more everywhere than now. Even if we think already right now, it's already everywhere. It will really be everywhere, and it will be part of any decision process. And to a large degree, this is amazing, right? It's like having some McKinsey, company that now charges you $1 million to figure anything out, just at the fingertips here. Everyone can just type in something and get the same kind of knowledge that otherwise some consulting company would charge you millions of dollars for, right? So it will be amazing for all of us, right? On the other hand, of course, and that was also brought out already, there's something about AI. It's this ubiquity and also the relentlessness of these algorithms that are here all the time, ever 24 hours, never need to sleep as long as they have some electricity, right? Always go on. That could very easily also get us into some nightmarish scenario, right? And so that brings us now these opportunities, but also the high risks are there. That brings us now to the question about trust, right? So how do we make systems that people will trust, and why is important? Now, I think in order to make systems that people will accept and will trust, and so then be willing to work with and interact with, and then also benefit from, clearly we'll have to make systems that make good decisions, right? If if you replace your doctor, at least, you have maybe a system that decides whether or not you have cancer or don't have cancer, what kind, or any other disease. You better be sure that the system makes good decisions, right? But you would also probably like to know in many of them, maybe you're being rejected from a job application, why this decision was made, right? And further, you also probably want to make sure that these systems are stable, right? Stable in the sense that they are not very sensitive to the input, that they behave in predictable ways, and that it's not easy to trick them, either maliciously attack them and you get security concerns, or simply by being not robust in terms of noise. Fourth, you probably also want to make sure that the systems are available to everyone. Current systems like language, for example, they have literally billions of parameters, need a nuclear-powered reactor to just power the electricity to train them, etc. That's clearly not something that everyone could just afford. So you would like to make sure that the access is there for everyone. Now, all of these, of course, intimately related to trust, right? I think if we don't be able to build systems that fulfill these basic criteria here, then I think people will not accept the systems. They will not make use of it, and that could cause, of course, a lot of trouble. So the question is then, how do we ensure? It's not a technical question, but how do we ensure that we actually go there, that we'll actually implement it? And so, how do we achieve this? And so there are many different approaches. The EU, for example, has commendable, taken kind of lead and has proposed that in the future, AI technology might be categorized, into something I think they have called, either technology unacceptable risk, high, limited, or low. And then the proposal was, any technology, let's say surveillance or something that has unacceptable risk would just be outright banned. The two middle categories would be regulated, and the one with very low risk could just be essentially free. And the argument by the EU was essentially, well, by getting laws there, we create essentially a legal security for companies to start their business. They will not be maybe like 5 years down the road be sued. That might spur potentially innovation. So that was one of them. And the second one is that it would protect people potentially from negative side effects, right? On the other hand, I guess if you ask some companies, they would say, well, any regulation might just be, hampering innovation. So let's not regulate, let's just self-regulate. Trust us, everything will be fine, okay? And of course, we have already heard before, and that might not be a very good idea either. So we have essentially two possible scenarios, in the extremes. One is think of every possible application and scenario and try to say whether or not this should be allowed or not. Okay, this looks very much like what AI looked like in the past, all possible scenarios that might be possible. And the other one is essentially perhaps no regulations per se, but perhaps efficient and credible mechanisms for some legal recourse. So you basically don't maybe start with laws, but you start simply with mechanisms to complain or to get recourse where certain things go right. Now, I guess realistically, you should be somewhere in between, right? There's certain applications where it's clear that nobody wants them. Nobody wants a full surveillance state, right? And so whether AI should be allowed to constantly have cameras everywhere and track you everywhere, that probably most people would agree that it should simply not be allowed that, okay? But then for all the rest, I guess AI is simply too fast, or any technology is too fast to regulate it by writing particular laws. Really, a much more flexible approach is probably called for. Good mechanisms for legal recourse, social pressure, perhaps trust labels or things like that are probably the much better way to regulate it. Now, that brings me back to the beginning about Jester. So the idea of Jester is to every year trying to go over the landscape and see what has happened. And science and technology typically comes in different cycles. So there's cycles where there's a jump, some tectonic shift, like, for example, the introduction of neural networks, or not so much the introduction, but the use of neural networks with the computing power and the necessary data that we had. And suddenly there was a jump in pretty much everything. And then this is typically followed by periods of slow and steady progress, something that kind of we are now where we're using this new technology, right? Now, I think we understand probably for the next 5, perhaps 10 years, where AI will be going. And so probably we can use that to trying to figure out where we should be going, right? Or what's technologically, maybe we should have said what's possible and then how we should be going. But it's probably necessary to really repeat this exercise every year or regularly because we simply don't know. We think that that's for the next years what happened, but who knows, right? In a year or two, a new model, a new technology, a new computing paradigm might come up, and suddenly we might find ourselves in a very different scenario. Okay, thank you very much.
And thank you very much to award-winning computer scientist, Dr. Rüdiger Urbanke, who is Associate Dean at the Swiss Federal Institute of Technology, EPFL. And if I had an AI-enhanced brain, that mix-up would never have occurred. Therefore, a good example of a use case for neurally networked brains in moderators. I would now like to introduce Ian Oppermann. Please, the floor is yours, and you may give your presentation from your seat.
Thank you very much. And thank you. I already had that very kind introduction. But I will point out that I am the Chief Data Scientist for the New South Wales Government in Australia, the first ever Chief Data Scientist for the state of New South Wales, principally in recognition of what's happening with data use and increasing use of machine learning and artificial intelligence. If I say anything controversial, I'm also an industry professor at the University of Technology, so I say it with that hat on, and anything controversial goes towards the university because we're required to push the boundaries when thinking about challenges like AI. The first presentation we had really showed just how overwhelming the possibilities of AI are, and I think that really is part of the challenge. There are so many different ways that we can engage with AI in the form of services. There are ways which we can use AI to augment our view of the world, our understanding of the world. We can actually put AI in our bodies. Retinal implant is a great example of incredible physiological, physical enhancement through the use of AI. And those of you who are old enough surely will remember the $6 million man who was a bionic individual who could do amazing things because of augmentation. We're also putting AI into physical structures. We're building smart materials, we're building smart systems, we're building communications into buildings, into aircraft, into the physical objects that we engage with. There are many, many different dimensions that we're engaging with AI. And the art of the possible is quite amazing. There's a company in Australia that uses AI to select embryos for in vitro fertilization, which is right on the cusp of what we're willing to do with AI and still call it appropriate and ethical use. The problem really is quite overwhelming. The other thing I should declare is that whilst I'm a scientist, my training is an engineer, and my dear wife is a barrister, which is a specialist lawyer. A lot of our friends are judges, and we sit around the dinner table having conversations about, from an engineer's perspective, from a scientist's perspective, AI and regulation. And then from a judge's perspective and from a lawyer's perspective, actually the way I should be thinking about this looks more like principles and frameworks. And I think the challenge we have is that we're actually missing a framework to assure the use of AI, as opposed to trying to regulate all the infinite possible uses of AI. An assurance framework which helps us think about some of the things which are unique to AI and are different to other emerging technologies like quantum, which are unique to AI and also allow us to follow some of the principles that were talked about earlier. So Philippe earlier talked about the importance of AI and the principles around how we should use AI. Sergio talked about the great work that the standards community is doing in the form of JTC1's SC42. And the counselor talked about AI serving humankind. And to some large extent, we still have a gap between the principles that we want to apply as we humanize AI and all of the things we need to do at the algorithm level, at the bits level, at the risk framework level, in order to ensure that the poor engineer, the data scientist, the data analyst, the algorithm developer really is doing things in a way which roll up to ensure that we are assuring the use of AI and appropriate use. Now, when we think about the infinite number of possible uses of AI that currently exist and what we could do in the next 5 or 10 years, it becomes bewilderingly complex. So fairly naturally, we turn to human principles about explainability, about trust itself, about the ability to unpack what's actually happening with that use of that particular technology. But very often, we apply a very substantial framework, a very substantial principle, without necessarily thinking about how we might pick out the parts which are unique to AI and are different to other technologies. If it was 1906 and we were sitting here, we may well be talking about use of electricity with trust. We'd be talking about the need for safety. We'd be talking about the need for transparency. We'd be talking about the ethical issues of the use of electricity. And it's not too hard to think about how you would take issues of ethics and equity of access, of safety, and a whole range of other issues and try to apply them to electricity and say, we need electricity to be used safely for lighting. People should have access to lighting. There should be rules about how you use lighting. And as we've seen over the last 100 years or so, that the use of electricity has changed dramatically from that first simple use case to running machines of a variety of different sources, to big, powerful electric motors, to things like domestic appliances, to use of powering electronics, and in fact, powering the AI that we're talking about today. And if we did swap out AI for electricity, just momentarily, and thought through that experiment, we could identify those aspects which are unique to electricity and yet would also be more generically applicable to emerging technologies. There are very similar forums to this one having conversations about appropriate use of quantum computing, the ethical issues associated with it, and what the challenges are about how we think through the appropriate uses of that technology. The challenge with something like AI is it's already everywhere. And if we don't build that assurance framework, we run the risk of a fairly strong societal reaction. We've seen societal reactions to things like genetically modified foods. We've seen somewhat strange societal reactions to 5G mobile communications and the thoughts that it might actually genuinely be connected to the spread of COVID. Because what we haven't done is necessarily found the ways to explain, to open up, to be transparent about the use of those technologies. We talk about transparency as being something we want from AI, but in practice, there are some sorts of algorithmic approaches which are not transparent. You cannot lift the lid and explain, often you can't lift the lid and explain what a convolutional neural network has done and how it's arrived at its conclusion. Now, similarly, it's very, very difficult to ask a dog at an airport who's sniffing out fruit or sniffing out bombs or even sniffing out COVID to explain the decision that it reached by saying, I think this human being is carrying an apple, or I think this human being has COVID. But we accept that situation because there are some humanizing aspects around the use of that intelligent, not artificially intelligent, but not human, intelligent dog. And of course, dogs are very nice to engage with most of the time. There's typically a human handler. There's typically someone who clearly represents an appropriate authorizing framework for the use of that dog. And if the dog gets it wrong, then of course it's very simple to undo the harm or the potential harm that's caused by the use of that sniffer dog. So aspects of transparency and aspects of explainability, whilst good in principle, may not actually be things that we really need to insist on if we can rehumanize that use of artificial intelligence. Explainability is one which is also would apply to that electricity example. Having studied as an electrical engineer, I can tell you explaining how electricity flows in a network is actually extraordinarily complicated. And it's something that at third year university, a lot of students really bang their head about it and come up with what's effectively a workable functional explanation, even if they can't do Maxwell's equations, which are extremely hard. We come up with a workable explanation of when we do this, we get this result. It's repeatable. It happens 99.999% of the time. So for the sake of us operating in the real world, we will say that that's a functional explanation of how that technology works. We can do exactly the same thing with AI. We can start to say that we expect this result from the AI, therefore we start to trust that we will get this result most of the time. Now, I mentioned, though, that in an assurance framework, we do need to focus in on the aspects of the technology which are truly unique, truly different to quantum or to data itself or to a whole range of other emerging technologies. And I do accept that argument that AI and data are very, very closely related. But there are a couple of things that AI has characteristics of which are somewhat unique. And mostly they relate to how we use the AI. AI can amplify, it can magnify. We know that it allows us to do things faster, potentially more efficiently. But there are very big differences between use of AI in a static, closed environment. You generate an insight, that insight goes to a human being, the human beings discuss it, they may use it or may not, versus AI, which is expected to make a difference in the real world, potentially in real time. And that could be an alert, there's something going on, you should have a look, an alarm, there's something going on and you're expected to go and have a look, a decision, I, as an automatic train, am going to close this door, and then an action, now I actually close the door of this train. Those aspects make AI really quite different to those other technologies. And when we're thinking about how we assure the use of a very potentially very, very complex system around risk and around potential harms, these are the sorts of ways we can start to think our way into that framework and map between the principles, those humanizing principles that we all want, and the bits of algorithm. But there was another point which was raised, and that's the adaptability of AI. The counselor talked about the fact that an algorithm could modify itself over time. That's a very, very different concept to a static, linear, rules-based system that cannot adapt. And so thinking through the consequences and the guardrails and the recalibration or retesting or reassertion of that assurance framework is really the way we can start to think our way into what's different about AI and how we would characterize trustworthiness of the use of AI with those different possible uses. Clearly a very different risk profile for a real-time, real-world system versus a non-real-time closed system. Clearly a very different risk profile if we embed it into our own lives, into our own bodies. Clearly a very different risk profile if we put it into a mission critical system such as a control surface on an aircraft where people are flying along, even if there's a human being in control. So where I believe we need to go is we need to, of course, keep having conversations at the principles level, because that's how we as people understand things. Those principles should be constantly checked, tested, argued, and tested against what do we actually want to achieve as a society, and that will be different in different societies, but the way of understanding what we're doing needs to be described in principles. Those principles really do need to map through the risk frameworks all the way down through the algorithms and down to the bits, and be able to map backwards and forwards for the different types of use of AI, for the different contexts of use of AI. And I think that conversation is something that not only will help me explain to my judge friends around the table, to my dear wife as we sit around the table, but it provides that common language which was talked about, that ability for everybody to say the same thing and mean the same thing as we start to think our way into what AI not only can do today already, but where it might go in the next 5, 10, or even 50 years.
Thank you very much. Just a moment, I want to open the floor for questions, but I would like to see whether first we could get the results of the poll from earlier on. Do we have those results? Are they available? Somebody over from the technical team could give me a thumbs up or down. Gather this means it's a thumbs down for now. In my email. Very good. Okay. We can't get us. We don't have it on a slide, I guess. Gavi? Okay. One moment. We'll just make a quick little. And we have largest share, not sure, 40% say they're not sure whether they trust AI. We have about 35% saying yes, they do trust AI. And the no's have about 25%. So that actually pretty much mirrors other polls that I have seen. I thought we might have a few more yeses, to be honest, because one thing we do know is that trust seems to go up the more that people believe they understand AI. And I would assume that this group possibly has somewhat more knowledge than average citizens. So interesting, 40% not sure. I'm going to ask the members of our keynote panel here to just comment on whether they find that result surprising, and would you have expected it to be higher, lower? Anybody? Anousheh?
I actually am one of those that the more I understand the potential of AI, and I combine that with the way our society is structured today, my trust levels go down, not up. So I expected more no's than not sure. But I'm not surprised. The not sure is because it all depends on how we take the next steps in creating that transparency, trust, and the right framework to use AI.
Yeah.
I think for me, AI is a little bit like walking in the Swiss Alps at the corner, at the ledge. Okay, it's amazing, but it's also scary. Okay.
Ian?
So I'm not surprised at all, to be quite honest. And I expect this audience to be a little more skeptical than most folks. And partly it's because there's been, I hope, more exposure to it. And one of the things we're also starting to see is that those organizations who really raced ahead and used AI are starting to have to unwind. So Clearview recently announced it would no longer sell its facial recognition software to private organizations. We've had that recent change to use of data sets like the Celeb 1M, where all of those faces of celebrities, they've had to try and pull back the release of all that data and the use for feeding facial recognition. So I think we're starting, of course, Cambridge Analytica, I think we're really starting to see where people have run too far ahead, where they've got ahead of the safety network and also public opinion.
Thank you very much. I have a couple of online questions here as well, and I'll put those out there, and then whoever wishes to speak to them, just give me a sign. First one goes to unconscious bias. Interestingly enough, amongst the risks discussed so far, we haven't heard that much about unconscious bias. We've certainly heard about transparency, explainability, and so on. But this question is the following. The bias of AI algorithms is a challenge that we're facing today. AI can show biased results when written by developers with a biased mind. How can the transparency of such decisions be ensured while implementing AI? Who would like to speak to that?
Technically speaking, I think it's not the algorithm that's biased, it's the data that contains the bias. Any bias we're aware of or potentially aware of, people can address. I guess the question is that there might be bias that we don't even know that is in there, and then that's technically very difficult to address. So I'm not worried about the one that we're aware of. I'm more worried about things that we simply don't know.
Anousheh?
I tried to address this a little bit by talking about how good the data set is, because the algorithm learns from a set of data. It recognizes patterns. Sometimes those patterns may be inaccurate because the data set is limited. We see the gender data gap quite widely affecting a lot of technologies that we're using today, whether it's voice recognition or a lot of image recognition, for example, that uses, looks at the skin, and the skin color has become an issue. But these are issues that I don't think the person who was, writing the algorithms was doing it because the person was biased. It was just that the data and the learning of the machine learning algorithm learned from a set of data that showed a different kind of a pattern that would otherwise. And we see this in drug development and other cases, especially with regards to gender, because women data has not been until recent years part of clinical trials, and a lot of data that's been collected, or it hasn't been identified, the gender hasn't been identified in the data set. So then the algorithm cannot make the right decisions when it comes to that.
I saw an interesting example of this mentioned in something I read yesterday in regard to the use of AI at work in workplace surveillance. That, for example, Black faces were often interpreted as being angry or impatient more often than white faces. So clearly, the data set had some issues. Ian, how do we get at that from a legislative or standards point of view, or conformity, compliance assessment? Is there a way to say, okay, we're going to require this, this, and this in a data set?
So I think the answer is hopefully yes. Hopefully we'll get there. The reaction I was going to give to that question was, we developed, the New South Wales government developed a first generation assurance framework during the course of last year, and we tested it on real projects. And what we did was, when we looked at a project and we had some discomfort with it, we said, all right, let's take away the AI part and see whether we still have discomfort. Let's take away the data part and see whether we still have discomfort. And if what we've got left we're still uncomfortable with, then it actually speaks to what we're doing as opposed to how we're doing it. Now, having said that, there are certainly things you can do to understand data quality, data balance, data bias. There are certainly things you can understand in terms of where the algorithm is going to take you. So whether it slices this way, whether it slices that way. But there are certainly lots of things we can do at the data quality level. And there's some really great work being done in JTC1 SC32 Working Group 6 around data usage in this space. So there's some baseline work we can do, but really we do need to think about what it is we're doing and whether what we're doing is appropriate.
Very much. And now I have a second question from the online audience, and then we'll take one or two live questions as well. Here's the next question. A Google supercomputer has created an AI child that can outperform its man-made rivals. This incredible machine is named NASN-Net. Can such a child look and work like an actual human? If yes, it could have both positive and negative effects. How can such challenges be dealt with? So a recognizability issue, among other things. Who would like to speak to that?
I think.
I'm not quite aware of a child, but I don't think we have general intelligence, artificial intelligence yet. So I think if it's a robotic system that physically resembles a child, I think it's quite ways away from actually being able to replace a child. However, it's all in the eyes of the beholder. There's scenarios, and one case study actually in Australia, that elderly people who lived by themselves or in homes were given an Alexa or unit that they could speak to, and they got quite attached to the unit. It didn't resemble any humanoid, but it just, because it talked to them. So I think in different circumstances, people can get attached to anything. We had pet dogs that were sold and they didn't do much and you got attached to it. So I think that has more to do with, I think, human behavior and knowledge and the ability of that machine that Google has made.
I have heard the argument, though, Rüdiger, Ian, that robots should not be made too deceptively human, or that if they are made deceptively human, something about them should essentially make the user or the interfacer realize that they are not. Would you agree with that?
Yeah, just what I heard, there were psychological experiments that if something is close but not perfect, it might actually be quite disconcerting to people. And so you either then make them on purpose slightly distinct and distinguishable, or you really make it perfect, and then it would probably be acceptable too. But there is kind of a sweet spot in the negative sense in which it can be quite disconcerting for people to interact.
That concept of the uncanny valley, as you get closer and closer, it actually becomes more challenging to engage with the technology. makes things like Shudu, the online influencer who's an avatar and who's designed to look like a supermodel, really an interesting concept. And then part of that bigger ethical question is, does it matter if you can tell it's an avatar or a piece of AI or not? And that's a really important question.
Very interesting question indeed. Who in the room has a question that they would like to pose? You all have microphones in front of you, but it would be great if you can give me a sign so that not everyone speaks at once. Please. And do introduce yourself if you would be so kind.
Hi, it's Ray Walsh from Dublin City University. Yeah, interesting that discussion there about the AI and the baby, and I think yeah, there is some similarities obviously because the AI doesn't always do what you expect it to do either. But the question is about we're talking about aspects of AI that we can't address every single use case that AI can possibly handle from a regulatory point of view or from a standards point of view. But at a higher level, do you think there's a chance or there's maybe a will even to come up with an AI Hippocratic oath, for example, like at a higher level from an ethics perspective, where the AI would at least agree that it will do no harm, and that approach could be maybe at a higher level a way to start rather than trying to do it from the bottom up.
All the hard ones to you guys.
Well, I guess it was alluded to, and I tried to allude to it also earlier. I think we agree that it's more about principles, like a Magna Charta or like some principles that should apply rather than specific cases. So some guidelines, what it should be. You can think of Asimov's whatever 7 rules or whatever, or principles of what AI should be doing or not be doing. I think that would be much more flexible and easier to have. And of course, this has to be backed up by some legal, efficient mechanisms to have recourse, whether or not when people think it's not being followed. But also social pressure, I think, can be a very, very good point.
I wanted to maybe add an alternative point of view where compare this to nuclear energy, nuclear power. I think we all agree that we could right now have clean, sustainable power if we could harness and make sure that the use of nuclear power is done in the right way. But also, we know nuclear power has been the cause of destruction. So if we look at, when I talk about transparency, we don't understand how, fusion happens. We don't need to know. But if people who are developing AI can be transparent about the use of AI and what they're developing, and there is that level of transparency, at least at the governmental level, just the way that countries that have nuclear energy or they enrich uranium, for example, they have to be registered and reported, and they're subject to inspection. A way for someone other than the company or individual be able to look into what's happening. I think that level of transparency will at least create a start of a framework where we can ensure that whether there is a promise not to do harm or regulation on certain uses should be prohibited or not prohibited. If someone is willing to open up and let someone see I'm doing good with AI, that gives me trust in that company or person who's developing it. If they're not willing to share that, I don't need to know how they're doing it. I just need to understand what they're using it for. And I think to me, that's the only way I would trust someone.
A certification that gave a seal would also have a similar effect, would it not?
That's going one level further, which would be great.
Is there another question out there in the audience before we take a break for coffee? There's in the back, please, and in the middle. So I'll go to the back first.
Hi, it's Navdeep Bihai from UK Atomic Energy Authority. Just to add to Ms. Ansari's comments, we are working towards a safe, sustainable nuclear energy. This is using nuclear fusion. So that research is happening. The question, I think I'm listening to all the presenters and especially Ian's comment about giving an example of an airport dog. With that, I think puts a bit of more context into what you're saying. However, I feel that we're still looking into a bit of restricted trust. Is that the case, or are we saying we trust AI, or we need to trust AI? Because the question is, why is it important to trust in AI? However, I get a feeling that we're still saying that we need to be a bit more, we're not harnessing 100% of AI's capabilities. Is that the case, or if you can explain a bit more, please?
I can respond to that. So thank you. Trust and trustworthiness are really important concepts, and there is actually a working group looking at trustworthiness of systems at the moment. And part of the issue is, do I mean that this system I expect it to behave? Or if I'm not the intended user, if I'm a bystander or a secondary user, or if I repeatedly engage, can I trust? Can I expect it to? Or if I take a broader perspective, is it potentially going to harm someone else or the environment or some other system unknowingly? So the concept of demonstrable trustworthiness in anticipation of developing trust are some important reframings. It's also important to think about the layers of trustworthiness and with regard to whom and with regard to what sort of potential real world harms or world risks. So I think when we think about trusting AI, it's important that we go beyond the simple algorithmic outcome and start to think about how it embeds and whether it performs as expected, and who is potentially harmed, and whether they're an intended operator or some bystander.
In the middle, I had a question.
Yes, hello. Can you hear me?
Yeah.
My name is William O'Neill. I'm with the Standards Council of Canada. Building on some of the comments that had been made earlier, talking about, the trust and what could help there. Do you believe that, the traditional forms of conformity assessment, testing and certification and whatnot, that they can help institute the same level of trust that those services helped with electrical products going back 50, 60, 100 years?
I'm also happy to have a go at that. I think the answer is yes, but it will require a little bit of rethinking to really adapt to what's unique about or special about AI. When we tried to introduce the assurance framework into New South Wales government, there was an ICT, information communications technology assurance process. The difference was the AI could adapt. And so being able to include that adaptive nature or some of those unique aspects, I think is where the conformity assessment folks will go. And we've got actually the head of conformity assessment for IEC in the room with us. So I'd recommend during the coffee break that that's a great conversation to have.
I agree. I think the certification, when we talk about trust, we can just talk about trust AI because we can't generalize it at that level. And I think trust is something that takes time. So something that can show you the company who developed the technology can be trusted. So it's not trusting the technology, it's trusting the actor who actually created the solution, the product, whatever it is that it's serving. That's how we can actually look at the certification or ways of using certification to create trust between us and the company, us, the actor, and the product.
Very much. Rüdiger, do you want to comment as well before we close?
Maybe just one thing. I'm slightly less optimistic, and the reason I'm slightly less optimistic is because AI pervades everything, right? The baker at this corner will maybe optimize their bread making recipe by using AI, right? So in many other standards, it's much more limited to something, electricity or maybe radio frequency usage and so on. Versus here, there will be virtually no aspect of life that will not be touched. And so it's not clear to me how could you make a standard for everything or a standard in general? I think I think you will do standards for very specific crucial cases, but then there will be all the rest.
Yeah, it would be a declaration. So as a company, I would say declare that I'm using AI in these ways. And if someone wants to inspect that, how it's used and the result, I have the results and the reports, I show it. So I get a certification. It can be like platinum, gold, and silver, but at least one, you'll be made aware that it's the company, the product uses AI, and second, that it has been certified by a third party or at least inspected by a third party. I think that's the only way, but we can't have a standard for every kind of AI. I agree. That's why I'm saying we should focus on the company.
Thank you so much.